My name is Holhake, and welcome to my final project, a counting circuit. Here, seen is the final PCB device counting up, and in this next clip, it will be counting down. Here's a quick look at the PCB board, inside the PCB case in the bottom of the PCB board, and the full counting circuit PCB. Next, I will talk about the NAND gate oscillator and its function within the circuit. Here is the schematic for the NAND gate oscillator. When the button is not pressed in the NGO, it presents a 9-volt current to the NAND gate, therefore presenting a low output, not powering the circuit. Next, once the button is pressed, it presents a ground to the button configuration, therefore presenting lows into the NAND gate, therefore outputting a high. This will then go through the diode and charge the 10 microfarad capacitor almost instantly. Some of it will also seep through the 1 mega ohm resistor, but while this is pressed, it will deliver the current through the second NAND gate. This will create a high, and then it will output a low, which will go through and then present lows, and then that'll output a high, which will output a high, which will output a low, which will then turn on the LED since it is a low on one side and voltage on the other. After the low on pin 3 has been processed through the 470 ohm resistor, it will present itself to the other NAND gate. This will then switch the output to a high, which will then make the other ones high, which will output a low, which will then output two more lows into pins 8 and 9, and then a high in pin 10, which will therefore turn off the LED. Simultaneously, this will also charge our 0.1 microfarad capacitor. Once the 10 microfarad capacitor is out of charge, the charge will then come from the 0.1 microfarad capacitor. This will send a high back through the 470 ohm resistor and switching the low on pin 2 back to a high. This will then change the output of pin 3 back to a low, which will change all the other inputs, which will in turn turn on the LED again. Essentially, this creates an oscillation between the two RC circuits, with RC circuit 1 being the duration of the oscillation and RC circuit 2 being the frequency of the oscillation. The next circuit is the decade counter. The decade counter takes this clock signal from the NGO and inputs it into a 4017 CMOS IC, and then from here, each of the outputs of the 4017 from Q0 to Q9 go into their corresponding inputs in the bar graph, and the carry out pin gets wired into a LED. The circuit's function may be seen here. The 4017 decodes this clock signal and transitions it into 9 outputs, and then the bar graph takes it and uses it to count from Q0 to Q9. Next is the decimal counting binary up-down counter. This counter takes the outputs Q0 to Q9 and carry out from the 4017 chip and transitions them into a binary counter. The 4 LEDs seen are in order from greatest value on the left to least value on the right, and it will count in binary up to 16 with a 4516 chip.
A cool part about this circuit is that it has a couple extensions. With the use of the 4510 and 4516 chips, we can use the up-down pin and put a slide switch with one of them going to 9 volts and one of them going to ground, and this will create a switch that when slided one way will count up, when slided the other way it will count down. Additionally, a reset button is used. For normal use, the reset pin should be grounded, but when it is connected to 9 volts, it will reset the count. So this can be used that when the button is pressed, it will connect the button to 9 volts, which will then reset the count.
The next circuit is the 7-segment display counting circuit. This circuit uses the 4511 binary decimal decoder. As you can see, it has outputs A through G. This will be simply wired into the 7-segment display, which has inputs A through G. Additionally, you can see that there are inputs A through D, which have binary values next to them. All the outputs with the line over them should be grounded for normal use. As with the 7-segment display, the one that we are using in this circuit is a CC, or common cathode, which means that it should be wired to ground for normal use. Here is the prototype on the breadboard for this circuit. As you can see, there are 680 ohm resistors wired into each of the inputs in the 7-segment display, and pin 3 on the top of the 7-segment display is wired into ground. It is important to have these 680 ohm resistors to ensure that these pins are not taking up too much current and that the segment does not blow. The final extension to this circuit is the dual-digit counting circuit. This circuit is simply an extension of the single-digit 7-segment display circuit, except that a few more chips were used to add a second display. This is the tens display. Essentially, you just take the carryout from the first one and input it into the second one, and take the same clock signal and divide it by 10 and put it in. Additionally, for extensions such as the up-down switch and the reset button, ensure to use the same button for both so that it resets both at the same time and it switches the count for both at the same time. Thanks for watching, and I hope you learned something new.